There is a reason mosquitoes keep finding you. Not the person sitting next to you, not the friend standing only a few feet away. You. And the strange part is that this decision may have been made long before the mosquito ever touches your skin, long before you hear the buzz, long before you feel the itch. Your body is already sending signals, invisible signals, signals that mosquitoes have evolved to detect over millions of years. On a warm evening, the air feels still, but for a mosquito, it is full of information. Every breath you exhale releases carbon dioxide, a faint trail, a chemical signature drifting through the air. To human eyes, it is invisible, but to a female mosquito, it is a clear beacon in the dark. From surprising distances, she can detect even tiny changes in carbon dioxide levels, and the moment she does, the search begins. She moves slowly towards the source, not knowing what she will find, only knowing that something alive is breathing ahead. As she gets closer, new signals appear. Your skin. Human skin constantly releases chemical compounds into the air. Most people never notice them, but mosquitoes do. Tiny amounts of lactic acid, ammonia, and other substances escape your body every second. Together, they form a unique scent, a scent as individual as a fingerprint. Some people naturally produce combinations that mosquitoes find highly attractive. Others are less noticeable. This is why one person may be covered in bites, while another sitting next to them remains untouched. The mosquito is not guessing. She is following chemical trails. Now she is closer, close enough to sense heat. The human body radiates warmth. To a mosquito, this warmth becomes a map. Special sensors allow her to detect tiny differences in temperature. She searches for a landing point, a place where blood is near the surface. But there is more information: moisture. Every breath releases water vapor. Your skin also emits moisture. These invisible signals help guide her precisely. And then comes vision. Mosquitoes do not see like humans, but they can detect movement and contrast. Dark clothing often stands out more clearly. Movement makes detection easier. Each signal brings her closer, closer still, until she arrives. She lands so lightly that you do not feel it. No warning, no sound, no sign of what is about to happen. Now begins what people call a bite. But mosquitoes do not actually bite. They use a needle-like structure called a proboscis. It slips through the skin with precision, searching beneath the surface, looking for a blood vessel. When it finds one, the mosquito injects saliva. This saliva contains chemicals that prevent blood from clotting and allow smooth feeding. Blood begins to flow. Her abdomen slowly expands, but your body reacts immediately. The immune system detects the foreign saliva. Histamine is released. The skin becomes red. A small bump appears, and the itch begins. Ironically, the itch is not caused by the mosquito itself. It is your immune response, a small biological battle. Within minutes, the mosquito is gone, but the story continues. Blood is not used for energy. Mosquitoes mainly feed on nectar. Blood is used for reproduction. It provides proteins needed to produce eggs, sometimes hundreds at a time. Soon she searches for standing water, a puddle, a bucket, even a bottle cap. There she lays her eggs. Life continues. Eggs become larvae, larvae grow in water, then transform into adults, and the cycle repeats. Mosquitoes have existed for more than 100 million years. They survived dinosaurs, ice ages, and global changes. Today, there are thousands of species. Small creatures, but among the most dangerous animals on Earth. Not because of size, but because of the diseases they can carry. And it all begins with something simple: a breath, a signal released into the air, and somewhere nearby, a mosquito is already following it.